Hello friends, today our topic is the equal matrices. That means the equality of two matrices. Two matrices Aij and Bij are said to be equal when they have the same number of rows and columns. That means the two matrices have to be in the same order at first, and also the elements have the same value. That means the corresponding position of the elements and their values are same for all admissible values of I and j. So what is the definition of the equal matrices? The two matrices A and B are said to be equal if A and B have the same order, the first one condition, and their corresponding elements be equal. Thus, if A is equal to Aij m comma n, that means the order is m cross n, and B is equal to Bij, that has to be same order m cross n, then A is equal to B if and only if we have Aij, that means the corresponding element Aij must be Bij for I is equal to 1, 2, 3 up to m, and j for 1, 2, 3 up to n. The number of rows in a matrix A, the number of rows in matrix B, and the number of columns in matrix A, that must be equal to the number of columns in matrix B. The corresponding elements of the matrix A and the matrix B are equal. That is, the entries of the matrix A and the matrix B in the same position are equal. Otherwise, we can say the matrix A and the matrix B are said to be unequal matrix, and we represent A not equal to B. So, for the equality of the matrices, we represent it by the equal sign, and for the inequality of the matrices, we represent it by the unequal sign. The two matrices are once again called equal if and only if number one, they are of the same order, that is the number of rows and the number of columns of one are same as those of the other, and number two, the corresponding elements are equal, that is the elements in the same position in both are equal. Let's check the conditions and the equality of the two matrices with some example. Now check the example here. As we have four matrices here, A, B, C and M. Now look at the first one matrix, that is A. A is the same order. A is the order has 2 cross 2. B has the order 2 cross 2. C has the order 2 cross 2. M has the order number of row is equal to 3, column is equal to 2. So we first check A and B. Now look at A and B are of same order, but look at the corresponding elements, that is A11. A11 is equal to 4, both are same. A12, here also A12 is, sorry, that may be B12 is also 13, that is B11, that is A11. Now that is second row, first column, A21 is equal to -2 and B21, that is also -2. A second row, second column, A22, that is also 19. Here we can found B22 also as 19. So we may say A is equal to B. Now we check with A to C. Here C11 is equal to 4, A11 is equal to 4. Those both are the matrices. A and C are of same order, 2 cross 2, 2 cross 2. Then A12 is equal to 13 and C12 is also 13. A21 is equal to -2, but here look at the thing, that is C21, that is 19. So that is not equal. The corresponding elements are not equal. So A is not equal to C, and as usual A must not be equal to M, because A has the order 2 cross 2 and M has the order 3 cross 2. So how we can find the equal matrices? And that has been described here. The A is equal to B because A and B are of the same order 2 cross 2 and the corresponding elements are equal. Here 1 1 element, that means A11 is equal to 4 in both 1 2 element is equal to 13 in both, 2 1 element is equal to -2 in both, and 2 2th element are 19 in both. So we can say A is equal to B. A is not equal to C because corresponding elements are not equal. Here we can check A21 is equal to -2, that means the 2 1th element of A is equal to -2, but 2 1th element in C is equal to 19. So A is not equal to C, and A is not equal to M because they are not of the same order. Here A is the matrix of order 2 cross 2 while M is the matrix of order 3 cross 2. Now look at the matrices. A is equal to 1 cross 1 and 1 cross 1. Now both the elements corresponding here, that is A11, that is B11, same. So we may say that A is equal to B because both matrices are of the same order 1 cross 1 and their corresponding entries are equal. For the second example, the matrices A, here we can also check that both the matrices are of order 2 cross 2 and the corresponding elements according to the position are also have the same value. So we can say here also A is equal to B. In the third matrix A, 4 6 1, that means 3 cross 3, here is also 3 cross 3. Look at the corresponding elements 4 6 and 1. So according to the corresponding elements, all the elements are equal in the first row. In the second row, the corresponding elements 2 5 and also the 9, that is equal, and in the third row 7 0 and -3. So also we can say here that A is equal to B. In the fourth matrix, that is also of the same order, that means 4 cross 4 4 cross 4. And also if we check at the corresponding position of the elements and their values, 2 2 -1 -1 6 6 5 5 5 4 3 -3 5 4 3 -3 7 -7 9 5 7 -7 9 5 and 2 3 8 4 2 3 8 4. So we may say here that A is equal to B. Let's check. Suppose that is not 4, suppose that is -4. If that is -4 and that is 4, only one element according to the corresponding value is wrong, then we may say okay, A is not equal to B. But here as that is 4 only and that is 4 also, so we may say A equal to B. Those are the examples of equal matrices.